Mars was supposed to be dead. But if scientists are wrong, it means something inside the planet is still alive. And if Mars still has heat, water, and activity, the search for life might not be about the past anymore. For decades, Mars was considered one of the most predictable places in the solar system. A frozen desert, a silent world, a planet that had long ago lost whatever life or energy it once possessed. From telescopes on Earth, Mars looked calm. Its rusty surface barely changed from year to year. Vast deserts stretched across the planet, interrupted only by enormous volcanoes and ancient valleys carved billions of years ago. Everything about Mars seemed to tell the same story. This was a planet that had died a very long time ago. Unlike Earth, Mars no longer had a strong magnetic field to protect it. Its atmosphere had been stripped away by solar wind over millions of years, leaving behind a thin veil of gas that barely held any heat. Temperatures could plunge to nearly negative 125 degrees Celsius during the night. If you stood on Mars today, the air would feel almost non-existent. The sky would appear pale and dusty, and the ground beneath your feet would feel like ancient stone that had not moved in ages. At least, that was the assumption. For a long time, scientists believed Mars had been geologically inactive for billions of years. On Earth, our planet constantly reshapes itself through earthquakes, volcanoes, and shifting tectonic plates. Mars was different, or so we thought, because in 2018, something landed on Mars that would begin to change that belief forever. It was a robotic spacecraft called InSight. Unlike previous missions that roamed across the surface searching for rocks or signs of ancient water, InSight had a different purpose. It was designed to listen. Buried inside the spacecraft was an incredibly sensitive instrument called a seismometer. Its job was simple but revolutionary: detect vibrations from deep inside the planet. If Mars was truly dead, the instrument would hear almost nothing. Just the faint whisper of Martian winds brushing across the surface. But that silence never came. Not long after the seismometer began recording data, scientists noticed something unexpected: tiny tremors. At first they were small, almost indistinguishable from background noise. But as more data came in, the pattern became impossible to ignore. Mars was shaking. These events quickly became known as marsquakes. And the deeper scientists looked into the data, the stranger the picture became. Some of the tremors were weak, barely detectable. Others were strong enough to ripple through large sections of the planet's crust. Over time, hundreds of these quakes were recorded. This was a shocking discovery, because earthquakes usually happen when a planet's interior is still active. They occur when stress builds beneath the crust, when heat inside the planet continues to move rock and pressure through its interior. But Mars was supposed to have cooled billions of years ago. So where were these quakes coming from? At first, scientists suggested simple explanations. Perhaps the planet was slowly contracting as its interior cooled further. Maybe meteorites striking the surface were sending shock waves through the ground. But the data didn't fully support those ideas. Some Marsquakes were originating from deep beneath the crust, far deeper than meteorite impacts could explain. Others appeared in regions that should have been completely stable. Slowly, a new possibility began to emerge. Maybe Mars wasn't as quiet as we believed. Maybe something was still happening inside the planet. And if that was true, it meant the story of Mars might be far more complicated than anyone imagined. But the quakes were only the beginning. Because while scientists were studying the planet's interior, orbiters circling above Mars started noticing something equally strange on the surface. Dark streaks were appearing along steep Martian slopes. Thin, shadowy lines that seemed to grow and fade with the changing seasons. At first glance, they looked like nothing more than dust sliding downhill. But when researchers examined them more closely, the patterns didn't quite make sense. These streaks appeared to flow, almost as if something beneath the surface was moving. And that raised a question scientists weren't ready to answer yet. What exactly was causing these strange changes on Mars? Because if the planet was truly dead, none of this should be happening. But the biggest mystery was still ahead. Because not long after the Marsquakes were discovered, another signal began rising from a Martian surface. A gas that should not have been there at all. The gas was methane. And on Mars, methane should not exist. At least, not for very long. On Earth, methane is constantly produced by living organisms and geological activity. Microbes buried underground release it. Volcanoes and hydrothermal vents push it toward the surface. Even decaying biological material can generate methane over time. But Mars is supposed to be different. Its atmosphere is incredibly thin, and sunlight quickly destroys methane molecules floating in the air. Scientists estimate that methane on Mars should disappear within a few hundred years. Which means if methane is being detected today, something must be producing it right now. And that discovery changed everything. Orbiters circling Mars had been studying its atmosphere for years, but it wasn't until the Curiosity rover began exploring Gale Crater that researchers started noticing a strange pattern. Tiny bursts of methane. Sometimes the gas would appear in the atmosphere suddenly, then vanish again weeks later. Other times, methane levels would spike and slowly fade away over months. At first, scientists assumed it was a measurement error. Space missions are incredibly sensitive, and even small calibration mistakes can produce misleading data. But as the rover continued sending information back to Earth, the pattern became undeniable. The methane spikes were real. Something beneath the surface of Mars was releasing gas into the atmosphere, and no one knew what it was. One possible explanation was geological activity. Deep underground, Mars may still contain pockets of heat trapped beneath its crust. If water once flowed through these regions, chemical reactions between water and certain minerals could create methane. In theory, this process could slowly release gas through cracks in the Martian surface. But there was another explanation, one that scientists approach with extreme caution, because on Earth, methane is most commonly associated with life. Microorganisms buried deep underground produce methane as a byproduct of their metabolism. These microbes thrive in environments with no oxygen, surviving in places that would seem completely hostile to life. If something similar existed beneath the Martian surface, it could explain the methane. But that idea opens a question humanity has been asking for centuries. Could Mars still harbor life? So far, no mission has found direct evidence of living organisms on the planet. But scientists know that billions of years ago, Mars was a very different world. Ancient river valleys carved across its surface. Massive lakes once filled enormous craters. Minerals discovered by rovers show clear signs that liquid water once flowed across the planet. In other words, Mars was once habitable. And if microbial life ever developed there, some researchers believe it might have survived underground, protected from radiation and the harsh surface environment. But methane wasn't the only clue that something unusual might be happening on Mars, because scientists studying satellite images began noticing something else. Certain regions of the Martian surface appear to be changing. Fresh cracks and fractures have formed in areas that should have remained stable for millions of years. Landslides have occurred on steep canyon walls. Entire slopes have shifted as if the ground beneath them is slowly adjusting. Some researchers believe these changes may be linked to the marsquakes detected by the InSight lander. If Mars is still experiencing internal stress, even on a small scale, it could explain why parts of the surface are subtly reshaping themselves. But it also raises a deeper mystery, because Mars is supposed to be geologically inactive, a planet that cooled and quieted billions of years ago. And yet, the evidence suggests something is still moving beneath the crust. Quakes, methane bursts, surface changes. Individually, each of these discoveries might have simple explanations. But together, they paint a picture that scientists are still struggling to fully understand. Mars may not be as silent as we once believed. And if the planet is slowly changing, we may only be witnessing the beginning of that story. Because the truth is, we have explored only a tiny fraction of Mars. Most of the planet remains untouched. Its underground caverns, ancient ice deposits, and buried geological layers remain hidden beneath miles of dust and rock. Somewhere within that unexplored world, the answer to these mysteries may still be waiting. And one day, future missions, or even human explorers, may uncover what is really happening beneath the Martian surface. But until that moment arrives, one thing is becoming increasingly clear. Mars is not the lifeless fossil we once thought it was. Something is happening there, and scientists are only just beginning to understand it. For centuries, Mars has captured human imagination. A red world hanging in the night sky, mysterious and silent. But the more we explore it, the more that silence seems to fade. Quakes shaking the planet's interior, methane rising from beneath the surface, and landscapes slowly shifting over time. None of these discoveries prove that Mars is alive yet, but they do tell us something important. The story of Mars is far from finished, and somewhere beneath its dusty plains and frozen deserts, secrets are still waiting to be uncovered. If you enjoyed exploring the mysteries of our solar system, make sure to subscribe to the channel, because the universe is filled with worlds we barely understand, and this is only the beginning.